So today we follow up with our properties of polynomials once again, and we're going to tackle the division aspect of this. We know that if I divide two numbers like 32 and 4, I can write it as a fraction as such. 32 and 4 also break down into exponents of the same bases. We have 2 to the 5th being 32, and then 4 is just 2 squared. We know that 8, the answer, is 2 cubed. So if you look at the relationship between the 5 and the 2 and the 3, we know that terms with the same bases, we must subtract the powers. So some other properties that exist is if I have a division of two terms raised to a singular power, then those two terms can be split up into the same base of that same power divided by each other. An example is 3/5 cubed is 3 to the third over 5 to the third, which is just 27 over 125. Another property is that if I have 25 over 25, we know that's equivalent to 1, and 25 is 5 squared, as is 25. When I take the principle of keep the same base and subtract the powers, I get 5 to the 0. And it turns out that anything to the 0 power, or n to the 0 power, is always equal to 1. So when we deal with negative exponents, another example is if I have 8, which is 2 cubed, and 32, which is 2 to the 5th, and I subtract those powers, I get 2 to the negative 2nd. However, we know that 8 over 32 is the same as 1/4, or 1 over 2 squared. So basically what we can say is that a negative exponent is the reciprocal of that base with a positive exponent. Some examples: 3 to the negative 2nd power is take the reciprocal of 3 to the 2nd, and you get 1/9. Likewise, if I have 1 over a to the negative 4th, I take the reciprocal of a to the 4th and make my exponent positive. In this case, m to the negative 5th, take the reciprocal and make the exponent positive. Here I have 2 to the negative 2nd, 5 to the negative 2nd, take the reciprocal of both, make the exponents positive, and there we have it. So let's take a look at this problem here. I'm going to reduce these fractions by simplifying. I have 16 over 6. I know 2 goes into both of those. We have 8 times here and 3 times here. Now, I see an a to the 5th, a to the 12th, which is the same as a to the negative 7th, and this is b to the 17th. However, we never give anything with negative exponents in the answer, so I take the reciprocal of that a term and make the exponent positive. b to the 17th stays on top since it's positive. Clean this up a little bit. We can either bring the 5 in and multiply exponents, or I can simplify the inside first, which is what I think I'll do following the order of operations. So notice what I'm going to do in this case. This is y to the 2nd. If I have 8 y's in the bottom and 5 y's in the top, that reduces to 3 y's in the bottom. Then I have a z to the 3rd. All that's to the 5th power. Now I take and multiply powers, so that's x to the 10th over y to the 15th and z to the 15th. So one rule that I use commonly is I find the greatest exponent of the base term, and the solution will be on that half of the fraction. So you'll see here, I could have done that in this case as well. Find the biggest exponent. There's a 12 and a 5, and then I subtract those two, giving me a 7, and the answer is in the denominator. Here, I use that exact principle. I have an 8 and a 5. Subtract those two, I get a 3, and the answer is in the denominator. I'm going to use that for the rest of the day. So in this case, I simplify the denominator first. That's 12x to the 14th over 3 squared is 9, and then that's x to the 20th. 12 and 9 are reduced to 4 over 3. Biggest exponent down in the denominator, subtract the 2, so that's x to the 6th in the denominator. Here I'm going to clean this up first. I have x to the 7th over x to the 4th, y to the 12th, because I took the reciprocal and made the exponent positive, y to the 14th. Now wherever I multiply, I'm going to add fractions. Wherever I divide, I'm going to subtract. So I have x cubed over y to the 26th. In this case, I'm going to use my power of a power. So that's 24 to the negative 1, x to the negative 1, and y to the 7th over 2x to the negative 8th, y to the 13th. I'll then take all the reciprocals I need to take. There's a 24, taking its reciprocal, making the power positive, x to the 5th. Take its reciprocal, make the power positive, keep y to the 7th here. Let's move down to the bottom. There's a 2. I bring this x to the numerator, make its exponent positive, and leave y to the 13th down here. So then we clean that up a little bit. I'll go a 2 and a 24 is a 48. Biggest power of x is in the numerator, subtract the 2, so that's x cubed. Biggest power of y is in the denominator, subtract 2, get y to the 6th. And that's my final answer. So I'm going to use my order of operations first and do everything inside the parentheses. I notice I have a 6 over 14, which reduces. 2 goes into both, 3 times here, 7 times here. I can take and reduce these x to the 9th and x to the 4th by saying that's x to the 5th. I'm going to clean this up a little bit, put my y to the 10th down, and keep my y to the 6th here. Still, I can combine the y terms. It's 3x to the 5th over 7y to the 16th. And now all this is raised to the negative 2nd power, giving me 3 to the negative 2nd, x to the negative 10th, over 7 to the negative 2nd, and y to the negative 32nd. Now I can take some reciprocals. That's 7 squared, y to the 32nd, over 3 squared, x to the 10th, giving me 49, y to the 32nd, over 9, x to the 10th. And again, that's all we've got today. Make sure you do your Connect Ed and your lesson summary, and we'll talk tomorrow.